use implicit differentiation. I'll capture as much of this picture as I can. To find dy dx if y plus cosine y equals xy, we would be hard-pressed to solve this equation for y in terms of x, although because it's not difficult to solve for x in terms of y, we can actually define a parametric curve and sketch a graph for this, either using a graphic calculator or I've done one with GeoGebra. But in either case, we can come up with an expression for dy dx in terms of x and y. So here goes. ddx of y plus cosine y equals ddx of xy. Differentiate both sides with respect to x. That's how it starts. On the left-hand side, it's the derivative of a sum. So the derivative of the sum is equal to the sum of the derivatives. So ddx of y plus ddx of cosine y. On the right is the derivative of a product, and for the derivative of a product, we use the product rule. It's the first times the derivative of the second plus the second times the derivative of the first. So we take the derivatives. ddx of y is simply the notation dy dx, the derivative of y with respect to x. Or you might say it's 1 times dy dx, but either way, that's what you get. Derivative of cosine y, derivative of the cosine of something, is the negative sine of that something times the derivative of that something. So minus sine y dy dx. Variable in the expression, the variable with respect to which we're differentiating do not match. Y is implicitly a function of x, not explicitly a function of x, because it fails the vertical line test, as we can see here. But when x changes, y changes, so I have to multiply by dy dx. Equals x times the derivative of y with respect to x plus y times 1. ddx of x is 1. We need dy dx. So although we cannot find y explicitly in terms of x, we can find dy dx explicitly in terms of, well, a mixture of both x and y. What we want to do is get all the terms, there are 3 of them, get all the terms that have dy dx's in them together on the left-hand side. So the dy dx I'll leave where it is. The minus sine y dy dx I'll leave where it is. And the x dy dx I will subtract from both sides to have minus x dy dx and then nothing but y on the right-hand side. What next? Factor out the dy dx. So get them all together on one side and then factor out that common factor. We have dy dx times the quantity 1 minus sine y minus x equals y. Then divide both sides by 1 minus sine y minus x, and dy dx equals y over 1 minus sine y minus x. So if we happen to know a point, any point on this graph, might not be the easiest thing to find, a point on this graph, but if we could find the coordinates of a point on this graph, we could find the slope of the tangent line by substituting the x coordinate for x right here and the y coordinate for y right there. So I'm suggesting that this point right there is actually on the graph. I think we should confirm that. Let's see if it's really on there. So if I substitute pi for y and pi minus 1 quantity over pi for x, I just want to confirm that it's a true statement and not something I just made up. I did make it up, but I think it's also true. Pi plus cosine pi equals maybe pi minus 1 over pi times pi. True or false? I guess if I erase the question mark, I can say true or false, but I'm not going to erase the question mark because it's still an open question. What's cosine of pi? -1. So pi plus -1. I'm thinking so. This equals pi minus 1. So yes, all I'm doing is confirming that sure enough, the point pi minus 1 over pi comma pi is actually a point on the graph. And it is. So when we substitute pi for y in this expression, and down here pi minus 1 over pi for x, it will actually tell us the slope of this tangent line. So we do it. I'm going to write it like this. Dy dx, where x, y equals pi minus 1 over pi comma pi. I really would like to have room to say something. What can I say? Oh, I can scoot this over. Shrink it just a bit. And then this over there. So dy dx, where xy is that point, is equal to pi over 1 minus sine pi minus pi minus 1 over pi. Substituting pi for y, pi minus 1 quantity over pi for x. Let's see what we get. This equals pi over 1 minus, what's the sign of pi? 0. Yeah, see, sine, what? Sine starts at 0, and then over at pi, it's equal to 0 again. So, it's 0 minus, I'm going to take this and write it pi over pi minus 1 over pi. How much more room do I have? Pi over 1 minus 1 plus 1 over pi. If we cancel the 1 and the minus 1, it's pi over 1 over pi. It's pi times pi over 1, pi squared. Yeah, this is pi squared. So the slope of the tangent line, m sub tan, equals pi squared.